Choosing the right CNC machine is crucial. It impacts your work quality, project scope, and budget. First, determine what you want to make. Will you carve wood, cut metal, or engrave plastics? Different materials need different CNC capabilities. Consider the size of your projects. A larger machine is better for large projects, but smaller machines are great for detailed work. Don't overspend on features you won't use. A basic machine might be enough for simple tasks. However, advanced features can be valuable as your skills grow. Think about the software you need. Some machines come with software, while others require separate purchases. Make sure the software is compatible with your computer and operating system. Research different brands and models carefully. Read reviews from other users to understand their strengths and weaknesses. Look for machines with good build quality and reliable components. Consider the warranty and after-sales service. A good warranty can save you money and headaches down the line. Setting up your CNC machine correctly is essential for optimal performance. Start with a stable and level surface. Vibrations can affect the accuracy of your cuts. Use a sturdy workbench or dedicated stand. Connect your machine to a reliable power source. Use a surge protector to safeguard your investment from electrical fluctuations. Properly install and calibrate the spindle. The spindle holds the cutting tool and its accuracy is critical. Follow the manufacturer's instructions for calibration to ensure precise cuts. Set up the work holding system firmly. Secure your workpiece to prevent movement during operation. Consider using clamps, vices, or vacuum systems for maximum stability. Install the appropriate software and connect your computer to the machine. Test the connection and ensure communication is smooth. Run a test cut to confirm everything is working correctly. Make adjustments as needed to achieve the desired results. Where you put your CNC machine matters. Choose a location with stable temperature and humidity. Extreme fluctuations can affect the machine's accuracy and longevity. Ensure adequate ventilation. CNC machining creates dust and fumes, so good airflow is essential for your health and the machine's performance. Consider noise levels. CNC machines can be loud, especially during cutting. If you work in a shared space, choose a location that minimizes noise disruption. Have enough space around the machine. You'll need room to move around and access all sides of the machine for maintenance and material loading. Think about lighting. Good lighting is crucial for setting up projects and monitoring progress. Install bright, even lighting around the machine. Ensure easy access to a power outlet. You'll need a dedicated outlet for the machine and potentially additional outlets for dust collection systems and other accessories. CNC machines can consume significant power. Understanding their energy needs helps you save money and reduce your environmental impact. Choose an energy-efficient machine. Look for models with high-efficiency motors and power management features. Optimize cutting parameters to minimize energy use. Using the right feed rates and spindle speeds can reduce energy consumption without sacrificing quality. Turn off the machine when not in use. Even in standby mode, CNC machines consume power. Develop a habit of switching off the machine when you're done. Invest in a programmable timer. This allows you to automatically turn off the machine at the end of the day or during extended breaks. Consider using renewable energy sources. If possible, explore options like solar panels to power your workshop. This can significantly reduce your reliance on grid electricity and lower your operating costs. Section 5. Dust collection and ventilation. Dust and chips generated during CNC machining can be hazardous, you know? Effective dust collection and ventilation are essential for your health and the machine's performance. It's wise to invest in a good dust collection system. Choose a system that matches the size and power of your machine. Ensure it effectively captures dust and chips at the source. Regularly clean the dust collection system. Empty the collection bin frequently and replace filters as needed. A clogged system reduces efficiency and can damage the machine. Ensure adequate ventilation in your workshop. Use exhaust fans to expel dust and fumes outside. Fresh air circulation keeps the workspace safe and comfortable. Consider wearing a respirator mask when operating the machine. This provides an extra layer of protection against fine dust particles. Choose a mask rated for the type of materials you're working with. Section 6. Efficient Programming and Toolpaths. Efficient programming and toolpaths directly impact energy consumption. Well-optimized programs reduce machining time, saving energy and wear and tear on your machine. Use CAM software to generate efficient toolpaths. CAM software helps you create optimized cutting paths that minimize wasted movement and reduce machining time. Minimize air cuts. Air cuts are movements where the tool is not in contact with the material. Reduce air cuts by carefully planning tool paths and transitions between cuts. Optimize cutting order. Machining parts in a logical order can reduce tool changes and unnecessary movements, saving time and energy. Use the appropriate cutting tools. Selecting the right tools for the job ensures efficient material removal and minimizes energy waste. Sharp tools cut cleanly and require less force, reducing energy consumption. Choosing the right cutting parameters is crucial for efficient and energy-saving operation. Cutting parameters include spindle speed, feed rate, and depth of cut. Experiment with different parameters to find the optimal settings for your material and tools. Start with conservative settings and gradually increase speeds and feeds until you achieve the desired results. Use online resources and machining calculators. Many websites and software tools can help you determine the best cutting parameters for your specific setup. Consider the material's properties. Different materials require different cutting speeds and feeds. Softer materials generally allow for faster cutting, while harder materials necessitate slower speeds. Monitor the machine's performance. Pay attention to the sounds and vibrations during cutting. If the machine sounds strained or vibrates excessively, adjust the parameters accordingly. Regular maintenance keeps your CNC machine running efficiently and reduces waste. Follow the manufacturer's recommended maintenance schedule. This typically includes lubricating moving parts, cleaning components, and inspecting for wear and tear. Keep the machine clean. Regularly remove chips and dust from the machine's surfaces. This prevents buildup that can interfere with operation and lead to premature wear. Inspect and replace worn parts promptly. Don't wait for parts to fail completely before replacing them. Proactive maintenance prevents unexpected downtime and costly repairs. Use high-quality lubricants and coolants. Properly lubricated parts reduce friction and wear, improving efficiency and longevity. Recycle materials whenever possible. Collect metal shavings and offcuts for recycling. This reduces waste and minimizes your environmental footprint. Choosing sustainable materials contributes to a more environmentally friendly CNC workflow. Opt for materials from renewable sources whenever possible. Look for wood certified by the Forest Stewardship Council, FSC, or recycled plastics. Consider the material's life cycle. Choose materials with a long lifespan and consider their recyclability at the end of their useful life. Minimize material waste. Carefully plan your projects to maximize material usage. Use nesting software to arrange parts efficiently and reduce offcuts. Explore biodegradable options. For certain applications, biodegradable plastics or bio-based materials can be viable alternatives to traditional plastics. Support local suppliers. Sourcing materials locally reduces transportation costs and emissions. It also supports local businesses and strengthens your community. Making informed decisions about your CNC machine leads to long-term savings and sustainability. Choosing the right machine, setting it up correctly, and operating it efficiently all contribute to lower operating costs. Reduced energy consumption translates into lower electricity bills. Efficient material usage minimizes waste and material expenses. Regular maintenance prevents costly repairs and extends the machine's lifespan. Sustainable practices benefit the environment and can lead to cost savings. Using renewable energy sources reduces reliance on grid electricity and lowers operating costs. Recycling materials minimizes waste disposal fees and reduces the need for new materials. Choosing sustainable materials often comes with cost benefits. Renewable materials are becoming increasingly competitive in price, and recycling programs can offer rebates or discounts. By embracing efficiency and sustainability in your CNC workflow, you contribute to a greener future while reaping the financial rewards of responsible practices. Remember, every decision you make impacts your bottom line and the planet.